So, what do we use transformers for? Well, when energy from a power station is transmitted a long distance to get to your house, so that your computer can run and you can hear my voice, well, those wires that transmit that energy, well, they have some resistance. And so the energy that travels through them, some of it is lost on the way. The wire heats up, and when some of the energy is lost to heat. It turns out that if you use a very high voltage and a low current, the energy loss is much reduced. And that's exactly what a transformer can do for you. It can take whatever electrical energy that comes out of the power plant, and it can increase the voltage and reduce the current. Doing this is called stepping up the voltage. And a step-up transformer works like this top one here. The primary coil has fewer coils in it than the secondary. In my example, the primary has 10 coils and the secondary has 200. So it has 20 times more in the secondary than in the primary. And what that means is that the output voltage coming out of the secondary going to the transmission lines is 20 times higher than the input voltage coming from the generator. So for example, if a 5-volt signal comes from the generator, it gets multiplied by 20, and a 100-volt signal will come out the secondary. This is again called a step-up transformer because the voltage increases, it steps up. Now, of course, when the signal comes to your house, it may need to be reduced, it may need to be stepped down, and so the reverse procedure can be used in a second transformer called a step-down transformer. In the one I've drawn, 80 coils are in the primary and only 10 coils in the secondary, so the voltage coming out the secondary will be 8 times reduced from the voltage coming in the primary. If there was 100 volts coming in, then it would be 12.5 volts coming out, and that's called a step-down transformer. So transformers can be very useful in this way. So here's the big picture. Maybe you're lucky and there's a lot of hydroelectric power where you live. So water's falling or moving and it turns a turbine, and that's attached to a generator, and we learned how that works. A coil of wire moves next to a magnet and that produces a current. And then there's probably a step-up transformer somewhere there at the power station, and those step-up transformers can increase the voltage as high as 750,000 volts. Very high indeed, and excellent for transporting long distances. So it goes a long way, and then it gets into your neighborhood, and that kind of voltage is dangerous to have near people, and so there are step-down transformers, one or maybe several in a row, that reduce the voltage down to a more manageable level. Probably 220 or 110. Let's say 220. And then the voltage comes into your home and turns on your light bulb so that you can do the homework. And your homework is to read section 8.3, answer on page 246, 1, 2, 3, 4, 5, and 7.